Hi guys, hello everybody, welcome back. So today we're back with Algebra 1 and my name doesn't matter. So we're going to be talking about more about factoring and expanding and I thought I finished it but I didn't. So for now we talked about like the basics, right? Now we're going to talk about some special cases. So one special case is A times B plus C. That's equal to AB plus AC. Right, that's the distributed property. You can also actually write it like B plus C plus dot 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 is equal to AB plus AC plus A dot dot dot. Okay, cool. So now we're gonna talk about the next one. The next special case is A plus B. Sorry, yeah. So the next special case is A plus B times C plus D. That's equal to and remember distributed property. That's equal to AC plus AD plus BC plus BD. Right? That should be a breeze. Hopefully, you've been practicing. Now, the next thing. Now, actually, there's a way to remember this special case because this one comes up a lot. So it's called FOIL. FOIL, I know it sounds dumb, but it's an acronym for FOIL. F stands for first, then outside, inside, last. What does it mean? So first means that we do the first term. So we have A and C, right? So we have AC. Outside means we talk about the outside. So it's A and D. That's the outsides, right? AD. Then the inside, B and C. So BC. Then last, B and D. Right? Simple. Next special case is A plus B times A plus B or A plus B squared. But we want to make sure that when we say that, we usually think it's A plus B squared. So what we call that is A plus B whole squared or whole cubed, right? So whole squared is, what does whole squared mean? If you do A plus B whole squared, that's A plus B times A plus B. That would be A squared plus AB plus BA plus B squared. And because AB equals BA, that's just A squared plus 2AB plus B squared. Now, if we had A minus B whole squared, we just plug in a negative B. So for B, so that means that we're gonna have A squared plus, or not plus, because B is negative now. This thing becomes negative, minus 2AB plus B squared. Still, it's not gonna be minus B squared because minus B times minus B is B squared. Remember, because negative 3 times negative 3 is 9. We're gonna talk about that later in the last episode or video or whatever. But yeah. Now the next special case is A squared minus B squared. That's equal to A plus B times A minus B. So it's a combination. Notice if you were to expand it, we get A squared minus AB plus BA, and BA is AB, so they cancel, the middle terms cancel. The O and I cancel, and this just becomes FL, which is A squared times B times negative B, or negative B squared. So you have A squared minus B squared. Now, the next special case is A cubed plus B cubed, or sorry, no, a squared plus b squared. That's equal to a plus b whole squared. But a plus b whole squared is a squared plus 2ab plus b squared. This is not the case. Remember, so I know some of you do this. A plus b whole squared equals a squared plus b squared. Done. That is not the case. I don't want you to even think about this, okay? Okay? Life ain't simple. Okay? It's not that. Remember, always use FOIL. Once you finally get this down, then you can move on. And a minus b whole squared is not a squared minus b squared. Remember that. A squared minus b squared is not a minus b whole squared. Remember this. A squared plus b squared, you can't factor this. Okay? Remember, you cannot factor a squared plus b squared. And that's just, I mean, you can kind of in Algebra 2, but do not. You just can't. So too bad. Now the next special case is going to be a plus b whole cubed. And that is equal to, how do you do this? If you just multiply it out, you're going to get a cubed plus 3a squared b plus 3ab squared plus b cubed. Now, a minus b whole cubed, that's a cubed minus 3a squared b plus 3ab squared minus b cubed. It's alternating, notice that, with the minus. And that's because if the power of b is positive, or if the power of b is even, like in this case, it's even in this case, and then also in this case it's even. In this case, b to the 0th, this case b to the 2nd. They both are even. So they both are positive. But the others, when they're odd, when the power is odd, so b to the 1st and b cubed, they have a negative. So cool. Now, a cubed minus b cubed. That is going to be a minus b times a squared plus ab plus b squared. You might think that this is a plus b whole squared, but it's not. There's no 2 here. It's just ab. Now a cubed plus b cubed. Now you can't factor a squared plus b squared, but you can factor a cubed plus b cubed. This is actually equal to a plus b times a squared minus ab plus b squared. So why is it that you can only factor these when it's a cubed? You can also factor it when it's a to the 5th plus b to the 5th, a to the 7th plus b to the 7th, a to the 9th plus b to the 9th, so on. So you can always factor it when it's a to the nth plus b to the nth when n is odd. Okay, but if it's even, you can't factor it. It's just how it is. I think there's some proof in number theory, but yeah. And that's equal to a plus b, I'm just writing the general form, times a to the n minus 1 minus a to the n minus 2 b to the b, right, plus a to the n minus 3 b to the n, no, b to the 2nd minus, and dot dot dot. What's the pattern here? Well, the pattern, oh yeah, and it goes up to b to the n minus 1. So the pattern here is that plus. So the pattern here is that it's the right minus 1, right? So squared in the a cubed plus b cubed. Then minus plus minus plus minus plus, right? And then the a goes down and down and down, while the b goes up and up and up. So now now we know that. And then a to the n minus b to the n, where n is anything in this case, is a minus b times a to the n minus 1 plus a to the n minus 2b plus a to the n minus 3b squared plus dot 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 all the way plus b to the n minus 1, n minus 1. So the pattern in this is there's no plus minus, plus minus plus minus plus, it's just plus 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 plus. And as a goes down, b goes up. Okay, simple. Now next one. Now you can keep going like a to the fourth, a plus b whole to the fourth, but I mean you don't have to. You can just follow a pattern, and that pattern you have to see in counting and probability. It's a weird pattern, and it links counting probability and algebra, and it's kind of cool. It's called the Binomial Theorem. Now what? So now we're gonna talk about if we had multiple variables, so a plus b plus c squared. We're not gonna do it for every single one that was above, but just this one. And then you might see a pattern later. So now, if you have many things, we don't really know what to do. You can't expanding it. It's really tedious and boring. So we're gonna do a trick, and it's kind of like u substitution. Well, it is. So now this trick is just by saying that, let's say that b plus c is let's say that let's say that a plus b is u. If a plus b is u, then we're gonna have u plus c squared. Hey, we know how to do u plus c squared. That's just u squared plus 2uc plus c squared. Now we plug back u equals a plus b, and we get a plus b whole squared plus 2a plus b c plus c squared. That's equal to a squared plus 2ab plus b squared plus 2a plus 2b, 2ac plus 2bc plus c squared. Notice that's just a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ac. This is every combination of 2 times a combination of 2 letters in A, B, and C. Then a squared, b squared, c squared. If you had a plus b plus c plus d whole squared, that's gonna be a squared plus b squared plus c squared plus 2ab plus 2ac plus 2 plus 2ad plus 2bc plus 2bd plus 2cd, I think. Every combination of 2 again. So yeah. Now you might think that that's always the case. If you had a plus b plus c whole cubed, you're gonna have a cubed plus 3a squared b plus 3b squared c plus 3ab squared plus 3bc squared plus b cubed plus c cubed, right? Blah, blah, blah. But you're wrong. If you did a plus b plus c whole cubed, you're gonna have what I just said, which means so I'm gonna actually just write that as the last one. Actually, second to last. There's one more. A plus b plus c whole cubed. That's equal to a cubed plus b cubed plus c cubed plus 3a squared b plus 3ab squared plus 3a squared c plus 3ac squared plus 3b squared c plus 3bc squared plus 6abc. Yeah, if you did, and then if you did a to the fourth plus d to the third, right? All that, just like a lot of weird things happen. But you're gonna study that in counting probability. It's called the binomial theorem. And binomial theorem, at the beginning, you only learn it with 2 variables, a and b, or x and y. Then you start to learn it with 3 variables. And yeah, it's just cool. So now, the last one, you don't need this one. I'm just starting it because it's optional. And it's kind of cool. It's a to the fourth plus 4b to the fourth. That's equal to a squared plus 2ab plus b squared, or plus 2b squared, times a squared plus 2ab, or sorry, a squared minus 2ab plus 2b squared. might think this is just a plus b whole squared, a minus b whole squared. But there's a 2b squared at the end of each one, not b squared. If we were to distribute this, I think I'm right, but might as well just check. If we distribute it, we get a to the fourth minus 2a cubed b plus 2a squared b squared plus 2a cubed b plus 4ab cubed plus 2ab squared, or 2a squared b squared minus 4ab cubed plus 4b to the fourth. Now this and this cancel. Wait, how'd I get that? How'd I get? Okay, and then how'd I get the second one? No, this is, wait, what? Did I do something wrong? A to the fourth minus 2a cubed b plus 2a squared b squared plus 2a cubed b minus, sorry, this is minus 4a squared, wait, what? Where did I get the 4ab cubed from? Wait, okay, so you have, sorry, I'm confused. So you have that, okay, now you have 2a cubed b, okay, then you have minus 4a squared b squared. Then you have plus 4ab cubed. 4ab cubed minus well, okay, I'm just gonna redo this just really fast. Okay, so you first have a to the fourth minus 2a cubed b plus 2a squared b squared plus 2a cubed b minus 4a squared b squared plus 4ab cubed. Okay, then you have 2 plus 2a squared b squared minus 4ab cubed plus 4b to the fourth. Now we see that this these cancel, negative 2a cubed b and 2a cubed b, 2a squared b squared plus this 2a squared b squared become a 4a squared b squared, and they cancel with this, and then you're left with this. Oh wait, no, then these two cancel, and then you get that. Okay, so I was right. Good. So I'm gonna rewrite this. Okay, cool. So yeah, this one is actually comes up a lot in Algebra 2, or in competition in Algebra 2 and pre-calc. But yeah. If there's more, I'll let you know. But other than that, that's it. These are the special ones that you at least try to memorize. But the key is memorizing. The key is understanding, right? Also, yeah, that's it. Okay, cool. So remember those special ones. And goodbye. Thanks for watching.